Hello everyone, welcome back. Welcome to this mobility session which was originally has been 7A, now it's 7D. The session is called Roaming and Internet Access Services Unleashed. Before we'll start with the presentations, I have two small things to say. One, please turn off your mobile phone to keep this thing quiet. And number two is please fill in your evaluation form. This helps us to optimize and improve the quality of the conference, so please do so. Okay, let's start. I believe the title of the session speaks for itself. It's a session that covers topics like the area of leading edge mobile technologies and wireless technologies within the academic field and beyond the academic field. Our first speaker is Klaas Wierenga. Klaas is a manager of in the middleware department of Surfnet. He has been involved in several international projects like in task forces. For example, he's the chair of the Task Force Mobility of Torino. He has been work item leader of JRA5, covering the mobility area. Klaas also calls himself the father of EduRoam. I believe that's true. And Klaas will tell us all about a rollout of a major wireless LAN project in the educational field of the Netherlands. So, Klaas, the floor is yours.
Thank you, Hans-Rudy. Right. Before I start, I have to make one apology to the viewers at home. I had a friend that was watching the stream, and she was also watching Josh Howlett presenting, and she said, "Wow, he really sounds like Hugh Grant. Are you going to be the same?" Unfortunately not. It's, in my case, just the body. So what am I going to talk about? A little bit different from what I used to talk about, but don't worry. The one picture that I always show will be in there. I'm going to talk about a project that we do together with our Dutch sister organization for primary and secondary education, Kennisnet. And it's a project that aims at bringing wireless to the whole educational column in the Netherlands. And, well, the contents speak more or less for itself, I would say. So, what is this all about? I hope this is readable from the back. If not, I'll read it. This is about what do users need and want, the bare essentials. This is a very famous cartoon in one of the major Dutch newspapers, and it's about this psychiatrist called Sigmund. And this guy comes at the doctor and says, "So, why is money so important?" Well, he said, the psychiatrist says, "It's very easy. Money provides you safety, and that is one of life's 4 bare essentials." So what were the other 3 again? Well, sex, drugs, and wireless internet. I think this sort of sums up why we are busy with that. And of course, we have this EduRoam service, or pilot services as some call it, or crappy service as some call it, but it is happening anyway. So in the world we have some pretty sizable deployments in Europe, Australia and Asia. Within Europe, as you can see, most countries and most research networks in Europe participate in EduRoam, and in the Netherlands, we also have a pretty sizable deployment of EduRoam. However, I would really like to tell you now that the same goes for the average Dutch city. In this case, that would be the city of Utrecht in the center of the Netherlands. Here you see a nice diagram showing all the wireless LAN coverage in the city of Utrecht. And wouldn't it be great if this would all be EduRoam enabled? Unfortunately, that is not. There is, to the right, you see some some blue spots, that is the University of Utrecht, that is Eduroam. In the center of the picture there's hidden among all these other dots, one dot called SurfNet, and then there are here and there scattered among the city some other spots. So what we really would like is to expand the footprint, and since we don't control the individual houses, we aim at expanding that footprint in education. And if you look at primary and secondary education, that is really a lot of locations already, pretty much all throughout the cities. But 802.1x is pretty complex. I promised you these pictures would come. Here is the first one. In itself, all the various elements are not so complex. It's the combination of technologies. In a typical university, you have someone that can configure an access point. There is another person that knows everything about radio servers, and there are probably some LDAP experts. So all together they manage to get this thing working with a bit of support. However, if you think about the average primary school with perhaps 200 students, 300, the math teacher that in his spare time does the network of the school, that might be a different story. But we do think this is the way to go, because it provides you this safe environment, which is especially in primary and secondary education relevant. You don't want every idiot around the corner to do bad stuff with the school network. Well, then there's of course Eduroam, which is even more complex. I put in slightly because I think if you have done an 802.1x deployment, then these 4 lines in your radius configuration that proxy unknown requests to another server is really not the difficult thing. So, to put it differently, the same Sigmund guy again. The problem is, this is this guy coming to the doctor and says, they think I'm insensitive because I never cry. Then the doctor says, well, if everybody gets emotional, you just have to cry with them, then they will appreciate you for it. And he says, I can't. And then at such a moment, Dr. Sigmund says, just picture yourself installing wireless internet, and there it goes. That is the problem we try to solve. Make it possible for the average administrator without a very thorough knowledge of all these technologies I was talking about to get a good deployment. These are some typical things people tend to say. It's expensive, we don't get it, it's so hard to do, it's so easy to make mistakes. We have these nice consumer programs on TV that illustrate these points. They already stop at the moment when the manual is only in English. That's probably, apparently for most people, already too difficult. It's not safe, of course, and if you have wireless, what can you do with it? Well, speaking for myself, the fact that I can sit with my laptop on the couch instead of having to go to the study to get to my fixed PC is already enough service. So to be very honest, I believe the important thing is to bring IP wireless, and the applications will sort themselves out. But a lot of people seem to believe that we really have to create these specific wireless applications to show how valuable a wireless network can be. So how did we go on about doing this? We created a joint project with the idea that within SurfNet we had a lot of experience, or perhaps I should even say within SurfNet our institutions have a lot of experience in deploying Eduroam, because the part that we do is actually very simple. We just route requests back and forth. The the real work is at the institutional level. So we thought we should somehow bring this knowledge to the schools. There are a couple of models that I will come back to but this knowledge should somehow find its way to the rest of the educational column. And to do that, we want to assist schools in deploying wireless networks and deploying these typical applications that have extra benefit if you do them over wireless. If you look at the primary and secondary education, even though they all had all kinds of mergers, etc., just like higher education, there are still a lot of them. I think there are 6,000 institutions of primary education in the Netherlands, and that pretty much means that we can't go ourselves to all these schools. Even if you would do a couple per day, then it would keep you pretty busy. So we need to find another way of doing that, and we usually do that by demonstrating how to do these things at a couple of spots, and then hope that the other schools will look at that and pick up the initiative. And another thing that we want to do is we want to look what is already happening in other areas of society. For instance, you have these municipal wireless projects where complete cities are have a blanket coverage of wireless, but usually no indoor coverage. Well, what we were thinking of is to sort of join forces with those initiatives and try to provide the indoor coverage for at least the schools and other not-for-profit institutions, so that you together you would get coverage everywhere, indoor and outdoor. And the idea is to get a certain scale to do these things by grouping sets of schools together, so that they together have this buying power to get this thing in place. So we formulated a project that consists of 4 major areas. The first one is making all kinds of existing content and services accessible for mobile devices. The second one is, well, if I just put it easy, bring Eduroam to the school, plus experiment with specific applications for wireless, like the one that always pops up, location-based services, these kind of applications. The third one is to deploy Eduroam technology in its municipal networks, so to make sure that we get this indoor and outdoor experience. And then after we have sort of shown how to do these things, scale the thing up, and in this case we aim to participate in a contest launched by the government, where they make available, I think, 1.2 million euros per project for initiatives that scale up small successful projects to a large scale. I will go through these 4 different areas shortly. The first one is really what you could say the low-hanging fruit. The idea is there are already a lot of applications that that with not too much effort can be made accessible over low bandwidth networks, or with devices with smaller screens and stuff like that. Typical things are group applications that we use, the Surf video portal and the Kennisnet video portal, but also already there exist a lot of applications out there that are used by teachers for to keep the rosters, to keep the attendance records of students and stuff like that. The picture I'm showing is a picture of the new mobile interface to our group solution based on Microsoft SharePoint, and there in the new version has an interface for 10 minutes. Wow. But you can't blame me if I go on and on, because it's so terribly hot here. So either I faint or I just keep on babbling. Good idea. So nothing rocket science here, just trying to make available what already exists, which makes sense, of course, because those are the applications that people use every day already. So you want them to be able to use them also in new circumstances. Second one is a little bit more exciting, but also there we try to use existing initiatives. I'm talking here about specific applications. We have a number of companies and research groups, etc., that have created really wonderful applications. Usually they are perhaps in the beta stage, perhaps a little bit further, but not really suitable for massive deployment. I put here a picture of one of such a application created by the Waag Society, a multimedia institute in Amsterdam, that has created a virtual history tour of Amsterdam. They currently use GPS and UMTS to do positioning, and then based on the place where a student is, they get information about what they're seeing right there, but they get also questions that they can answer, etc. I think it's probably not really readable, but there are some text that said the answer given is okay, you're at this percentage of the questions, stuff like that. There are a couple of initiatives already where groups of schools together want to deploy wireless networks, basically we go to them and we try to convince them that the right way to deploy such a wireless network is by using the technology, at least, that we developed in the course of EduRoam. If not EduRoam itself, then at the very least 802.1x. That means that if they in a later stage would want to participate in EduRoam, they can easily do it, but at least they have a safe and secure environment in the school. To do that, we have to do some extra work though. The SKUW2 client, Josh mentioned it already in a previous session. It's a wonderful tool. It's used everywhere on the globe. It's immensely popular, but it's not yet double click on the installer and off you go. And that is what we need to get if we want to deploy it on such a wide scale. So in fact, this you might have seen already that there are a number of improvements to the SKUW2 client already. We are taking it step by step, making it available for Vista, stuff like that. All these things that are coming out of the SKUW2 project are currently paid for by SurfNet, but I encourage you to participate in paying them to do more wonderful stuff. And we have to create lots of documentation. Partly we just take the stuff that has been created in JRA 5 and TF Mobility, but partly we have to really develop different stuff. And the idea is to come up with a blueprint. How do I create a wireless network in my school? And there are some questions, and basically what we want to do is we want to try out a couple of models. We have a number of schools that participate, and we have approached different vendors, and we just want to see what setup works best. So do we want to do a centralized approach where one service center manage the wireless for a group of 10 to 15 schools, Or do we say, no, that gives too many disadvantages, it is really important that the school does it themselves, but then of course it means we have to make sure that we can do it really cheap, otherwise it becomes too expensive for one single school. And probably the answer is not one of the two is the one answer. It depends very much on the school, how big it is, how much IT knowledge is there, etc. So probably we will end up with something like 2 cookbooks or 2 strands in that cookbook. Third main part of the project is Municipal Wireless. We really like to get involved into a municipal wireless project. The problem is they're not really happening yet in the Netherlands. With one exception, the University of Groningen has launched an initiative together with the other University of Groningen in Dutch. They have different names. They're not both called university. It's like a polytechnic and a university. Together with the province, the city council, and academic hospital, they want to create this blanket coverage over the city. And what we participate in that is that we have extensive experience with traffic separation, with authentication, authorization, stuff like that. So what we try to help them in developing a technical setup that allows them to get a decent business plan, and in return for that we expect, and the university demands, that they provide at-your-own access all through the city. And then of course we create again this indoor wireless coverage that already exists in the universities but not yet in the other parts, in the other schools. To do this we have created a report, a study that you can find under the URL that I mention here, and that investigates how to do a wireless deployment in a city, including all kinds of cost estimates, etc. The thing I want to mention is that what we found out is that the situation in the Netherlands, and I suppose at least also in the Nordic countries and UK, is pretty different from the situation in the US. The broadband penetration here is much higher, whereas in the US most of these initiatives somehow are aimed at making the digital divide smaller and stuff like that, whereas here very often the first question you get is, yes, but I already have ADSL, why would I want this? And that's actually a tough question to answer if you aim at replacement of the fixed access. But that is not what we aim at. Indoor coverage in these plans, it's, as far as I have seen so far, impossible to create a decent business case that provides indoor coverage. Too many uncertain factors, all these different types of buildings, trees, metal in the walls, stuff like that. So then the last bit, also chronologically last, the idea is we start with 3 parallel strands that try out things, and then what we learn from that we're going to do in this 4th bit, and that is combine the buying power and the technical know-how of a bunch of schools, and perhaps with the university, and let them together buy this service and perhaps run a joint operations center. We see one example for that in the city of Nijmegen. The university already maintains a lot of the service for a bunch of schools in the city, so it's easy for them to also do the radius server and perhaps some other servers. We want to use the model that we successfully used to create fiber rings in city that connect schools, that you can read all about in the proceedings of last year's conference. And we want to have at least 2 or 3 consortia to participate in this prize draw. The thing is, that is not, of course, what will reach the massive deployment. That is only to show that it can be done, and that's something that we have a lot of experience in with SurfNet. When we're talking about fiber to dormitories, fiber rings through cities, fiber rings to schools, that if you show that you can do it, and if you can present a business case that other initiatives can also understand, then they will follow. And this is aimed at setting the example and have the rest of the country follow. And then we will end up in the end with this utopia where I could show this map of the city of Utrecht again, but then all the blue dots would be at Jerome enabled. I'm not going to summarize what I've been saying so far because the chair is already getting a bit nervous on his chair. So I'm going to close with that. If you want to know more information, please come to me or ask questions now. Thank you.
Thank you, Klaus. So, are there any questions?
Just a random thought. In the Mountain View Google Wireless setup, it seems that someone's been selling these small boxes that you can put on a windowsill, which will take out the outdoor signal and broadcast them indoor. Is that an option that you have investigated for getting indoor coverage of your systems?
Yes, we have. We have actually discussed it quite extensively because that same random thought came also to my mind, so perhaps it was not that random after all. The problem is this consortium that wants to run the municipal wireless system has a business case that is very much aimed at a wholesale model. They want to steer away from individual subscription, and when you want to do this, you pretty soon end up with administering individual users because they will use it then as replacement for the wired connectivity. And the university has just got all their students on this wonderful SurfNet ADSL service, so they are very afraid of losing that revenue. Personally, I think that is a very interesting model to look further into. I just don't think it is at this moment, this year, achievable.
There's one more question.
Thanks. Two connected questions. How big this school consortium do you have in mind? I mean, how many schools in one buying power center?
For instance, in the city of Nijmegen, we're talking about between 7,000 and 10,000 students, a bit depending on which schools participate and which not, but roughly that size. So comparable to a small university.
And who manages or who will manage the identities of users?
That is actually a very good question. Originally, this sister organization of SurfNet, Kennisnet, had assumed that everybody would want to use the central identity management system that they use, a little bit like the Athens model in the UK. It turns out, however, that the identities in that system are not that well kept. Basically, whole schools use one username password or sometimes 1 year. And so we thought that would be a problem. Turns out that all these schools have wonderful identity management systems, apart from the fact that they're usually based on Microsoft Active Directory. But that aside, they do identity management. They are much further in the use of IT than At least I thought. So that's not really a big problem. They have it in place.
Okay, once more, thank the speaker. Thank you, Klaus. So our next speaker is Kurt Baumann. Kurt Baumann is working for Switch, the Swiss Education and Research and Education Network. He's been involved with Switch since 2005 as the project leader of the Swiss roaming solution. And Kurt will tell us all about how to integrate EAP SIM in the academic environment. Kurt, the floor is yours.
Thank you, Hans-Rudi, for your introduction. And good afternoon, ladies and gentlemen. Welcome to my speech about extending Switch public wireless LAN with EAP SIM at the educational institution. So let us go forward to my agenda. And this agenda I would like to divide into three main parts. The first part, I give you some introductions about how we have implemented Switch PVLAN in Switzerland and which components are in place and what's exactly a symmetric approach. That's the first part. The second part, I will give you some information about an EAP SIM, what's the deeper meaning of EAP SIM, and how we have implemented or used the knowledge for implementations of form of EAP SIM at the educational institutions in Switzerland. And last but not least, I give you some statistics that you have some visualization, how is the usage of this PVLAN in Switzerland. So, okay, let us start. And what do you think about this picture? What is, and this the motivation and for PVLAN? And the answer of this is we would like to make our students more flexible with the implementation of mobile technology. So at the beginning of 2004, we have also, we was in common sense with the educational institutions, academic association, and the commercial ones called WISPs, wireless internet service providers, that you would like to implement the symmetric approach. This symmetric approach means that the students or the students from the educational association could gain access to the internet as the conditions they have at its home organization. This means free of charge, and in returns, commercial users from the WISPs here, from the WISPs, including Swisscom, has the possibility to gain access at the campus as the same conditions they have at their providers without additional fees. Okay, so the one main goal that we would achieve is the extension of the footprint. The extension of the footprint means that we have our students in Switzerland, and all these students which participate at this PVLAN could gain access at the public places, for example, at the airport, for example, at the railway stations, for example, a lot of hotels in Switzerland. And this means that we could be mobile, and we can solve our problems, communications problems, at this station. So on the other side, we give the infrastructure, or we extend the infrastructure with commercial aspects, and so this is a good mix for introducing or for producing a PVLAN at Switzerland. And the requirements, we have here a statement about switch PVLAN should be implemented on switch mobile concept. And switch mobile concept in Switzerland is a classical VPN solution. So switch PVLAN is a modular built up on these solutions, and allows us that on the educational side that they know exactly which user uses PVLAN, and on the commercial side they know exactly how many students are there and will connect to its home organization. The second part is it should be cost minimizing for universities, that we have a modular grow up on these VPN solutions, that we have the main technology is in place. So we have to edit some configuration and some tools or some intelligence for producing PVLAN in Switzerland. Then this very interesting aspect, PVLAN should be combinable with eduroam. I had said I will speak about the extension of switch PVLAN with eAppSim, and this includes that we use the IEEE 8021X standard in combination with the authentication framework EAP, and especially eAppSim as method. So let us go to the symmetric approach. That what you see is the academic side here, and that's an example with University A and University B. And intelligence, as I have mentioned, is a multi-provider portal, or the captive portal in place, which has an access control list. And this access control is a whitelist, and the functionality of this whitelist is like a firewall. So I can show you and give you 3 scenarios on this architecture. The first one is a student from the University A can start a VPN client and gain access at his home organization through this VPN gateway. And the second one is a student on the place of the WISPs gain access to, on the same mechanism, gain access to his home organization by starting the VPN client. This is a really simple solution for our students. So the more interesting part, or the additionals that we support, is you can imagine this, you can see that we have here on the academic places a customer, commercial customer, and this customer would like internet access or gain access to the internet through our architecture. So if he is on the place here at University A, he will start a browser session, and on this browser the MPP will present him a landing page. On the landing page, on this landing page, you can find iframe or bottoms, like bottoms, and these iframes are all providers which are enabled in this project. And behind these iframes, there exists a GRE tunnel direct to the WISP side. So in the next step, after he has clicked on this iframe here, so he will forward it directly to the landing page. The landing page is in place, or will be presented from the WISPs, their users, and the user can authenticate it with a username, password, and gain access about their uplinks of the WISPs to the internet. So this is a very interesting aspect. So we can share the infrastructure, or the academic infrastructure, with the commercial one. Okay, now I have mentioned that we have this system, or this symmetric approach, or this architecture model extended by eAppSim. And if you can understand what eAppSim is, I give you a brief introduction to this subject. So EAP is handled in the RFC 3748 and it's a shortcut for authentication, extending authentication protocol, and is an authentication framework which supports multiple authentication methods, and EAP is running typically on layer 2. It's the base for EAP. This authentication framework we needed, and now we would like to choose the SIM mode on it. So for the model, how it works, I have divided it in 3 parts. The initial parts, established data link, and the first part is the identity exchange request paradigm. And this is like a lockstep protocol. That means if you have a request is started, that you will get response first of this request before we'll start the next request. So the second part is dependent on which authentication mode you have chosen between the supplicant and the authenticator, and between the authenticator and the authentication server. It's important to know, or it's depend on which system you have in place. For example, a radio server, for example, cooperative identity servers, and so on. And last but not least, the final is the authentication message, success or failure. That's the ending of the EAP protocol, of the mechanism of EAP protocol. So now we have to choose. We would like to choose the SIM method. So what EAP SIM? EAP SIM is a mutual authentication session key agreement which comes up. It grows up from the GSM community, and is a generation 2 authentication mechanisms, and handled for or built up for gadgets of generation 2 devices, and is more or less really secret mode. So what I will give you, which information I will give you is especially the authentication process. This is important for us, as we know the EAP mechanism. So what's happened on this part? We have a client in place with a SIM card. A SIM card, it could be a handy with a SIM card, it could be a laptop with a network card, on SIM card in it. In Switzerland, we speak about mobile unlimited from Swisscom, Orange Office card, for example, and by Vodafone they have a similar system that they can seamless authentication. That's exactly the aspect what we would prefer, and this was a requirement for a form of implementation on Swisscom side. Then Swisscom told us that it's very important to know that all products they offer their customers, they could be allocated at the academic places. So what's happened after finishing the identity exchange mechanism? We will have an EAP request SIM start would be passed, and at the client where the SIM card is in it, a SIM calculates a random number, and this random number, including with the user identity, the IMSI identity, this is International Mobile Subscriber Identity form, will be routed by the EAP request SIM start. So at the authentication backend radio server on this place here, EAP extending protocol will be started and will be formulate a request for GSM triplets. GSM triplets, as you can see here, includes a random number, a response random number, and a public key. And what we would see, or what's important in GSM, is in the first step, the server authentication. That means the RAND and message authentication, the message authentication code that the radio server here, the backend radio server here, calculates will be verified by the SIM card, and is it successful, the server authentication is passed. So to the second one, the client authentication is the other side, and if we have finished this process, then the server is authenticated and the client is authenticated. Now, what's the next step? How we can use this process or this knowledge for an implementation or a form of an implementation of ePSIM? So we have to define a project organization, we have to define an architecture, we have to define a proof of concept and the rule-out concept. So for the architecture, you can see here that the educational institutions in Switzerland is represented by the Swiss Federal Institution of Technology with Switch on the academic side, and on the commercial side by Swisscom. And the implementation will be passed at the Swiss Federal Institution. And so all technical expertise we have done will be introduced in the rollout. I'm sorry. So as we have spoken about this architecture, the first ideas was we have to was a centralized solution and then decentralized solutions. The ideas behind this is that on this way, Swisscom router is implemented, centrally implemented at Switch, and all educational institutions have to produce or to build up tunnels, GRE tunnels, and the bottleneck of this system is the ADSL connection. That means that this is a single point of failure, because you can see if you have 20 or 24, 200 participants in this model, then the problem will be is the system will not scale. Then each educational institution has to build up a tunnel, and the bottleneck will be really at the ADSL connections to the Swisscom data center. So the other way is we decentralize the system. So at each educational institutions you have in place SCM router with dedicated ADSL connections through the broadband customer services network from the Swisscom. So how we should let us should go a layer deeper, and what we have to implement is 802.1x enabled access points and web, VPA, double VP, VPA encrypted networks, and the traffic, the ePSIM authentication and accounting traffic will be directly routed to the Swisscom router. On this place, there exists a source not destination, and you have to build up for this implementation a mobile ePSIM, especially VLAN. So why that? The situation is that the client from Swisscom has a hard-coded mobile hard-coded SSID inside, so all clients will listening only on this SSID. So you have separately defined at each educational institutions a separate VLAN. So at the ETH, or Swiss Federal Institutions of Technology, we have implemented this, and so the requirements, the setup is we need really a mobile ePSIM SSID. The authentication is on the layer 8 on the standard IEEE 802.1x, and for the radio server, the ATS set has specially reserved a public address for the ePSIM traffic. So the problems from this implementation is that the system is not really scalable. our imagination or our ideas is to implement a multi-provider capable infrastructure that we can support a lot of providers they would like to use the educational or academic places. So the rollout, I'm sorry, is still going. We have running the Swiss Federal Institute of Technology, the University of Applied Sciences in Bern, the EPFL in Lausanne, and we will step-by-step implementation. We make a step-by-step implementation on this way. So our goal is to finish the project at the middle of Q3 07. So now to the statistics. Switch Association represents now more than 79,000 people, this academic association, and included are more than 2,000 hotspots. So we can gain, we have a big footprint enlargement in Switzerland, and our students can gain really multiple, a big possibility, or a great possibility to gain access at the public places, and are very mobile, I think. What's the measurement of this model? I have said that we have some iframes in place, and the multi-provider portal will give you the landing page, and on the landing page, behind this bottom, we have built up to the commercial world and GRE tunnels, and from the commercial world, we measure this traffic here, download, uploads, and from the commercial places, we measure the VPN connections to the home organization. So now some statistics. You can see here, that's the download free. That's the traffic from the educational institutions, from the students at the WISPs, and here is the end of the exam session, and here the start of the semester, and now the curve is going down. So we have a 1-year period here, and we can say that our PVLAN grows up, not linear, but this is a good evolution. So what the market share, we can say that more than 51% is on Swisscom side, the greatest carrier, the biggest carrier in Switzerland, and the only one that offers at the customers eSIM, and the other one is Monsoon, for example. That's the 23% TPN, and that's the other WISPs included in this project. What's the outlook? I have said that we have, it's not a scalable architecture that we have implemented, or infrastructure, and at each educational institution a captive portal is in place, and what we like to do is to extend this captive portal with a radius proxy, and we would like to centralize all EAP authentication traffic at Switch, and Switch has a proxy server in place based on the IEEE 802.1x and based on the EAP SIM, for example, EAP PEEP, MSCHAP version 2, and so on. And yeah, that's the future. And the problem in this, or open issues from the network side, or which is responsible for the NAT, should NAT be done at the place of the provider, should NAT be done at Switch, or So that should not be done at the educational institutions. The reason is that they don't like NAT for the users. So we are in charge, I think, and we have to build up this central proxy in the future. So what's the conclusion? We have a footprint enlargement. This is on both sides, on the academic side and the WISPs. We have implemented state-of-the-art switch PV-LAN on the current standard 802.1x and on the authentication frameworks EPSIM. And last but not least, with the realization of such multi-provider capable infrastructure, the user population will be enlarged, and so our students will be mobiler than they are at the moment. So, thank you for your attention.
Thank you, Kurt. Are there any questions?
A couple of years ago, we have also done a EPSIM trial, and I have two questions actually. First one is, why not go all the way with 802.1x? Why end up with this captive portal? Because you
Yes.
authenticate users,
Yes.
so
Yes.
you put them in a VLAN,
Yeah.
and you're set.
Yeah.
You can do the at your home thingy. The other thing is, in our trial, we terminated the EPSIM request at our side and not at the mobile operator side. Have you looked into that? We just, based on the realm,
Yes.
routed it to our radio server that did the actual authentication.
To the first question. That's right. We have some synergy about this implementation that I have presented you, and the idea in the future could be, and it was a statement of the provider, that we could be all services enabled on the IEEE 802.1x. And it's an idea, and I think for the future this is a very good aspect, and we have to do it, and we have to make a proof of concept that we could implement it in the future at our educational institutions. Yeah, that's right. And to the second question, this is, I'm sorry, this about, I'm sorry.
Why didn't you do the authentication of the user instead of
Yes,
Swisscom?
yes. I have checked this, and the first idea was we could handle the triplets at your own organization. The challenge is you must have a connection to the GSM authentication center, and the connection between the radius backend radio server and GSM authentication server is the SS7 gateway, and this SS7 gateway comes from the GSM world, and this is really a very expensive network. So each request and response you have to pay, and the other situation is if you handle these triplets on your location, so you must be a provider of SIM cards.
What we did is we had a GRE tunnel between our server and the GGSN of the operator.
Yeah, but the question about this, or the problem, is scalable if you have 300-400 participants. So the management or the build-up or the centralizing, the management of the EPSIM data flow, you have to manage. You have to manage this locally. So
Let's take this further offline.
One last question over here. Is answered already? Okay. Someone else? There would be room for one more? If not, thank you, Kurt. This takes us to the last speech of the day. I'm happy to introduce you to Ferdinand Holmes. Ferdinand has a degree in computer science from the University of Bonn. He has been working for one of the two big German research centers for the Fraunhofer Gesellschaft since 1975, mostly involved in international projects focusing optical networks and gigabit Ethernet. And Ferdinand will tell us all about on-demand provisioning of Ethernet systems.
Thank you very much. My presentation is about light paths which can be set up via signaling, and these light paths are set up from Uni Clients over SDH networks. And I will report on the tests which we have performed. Which one is it? This one? Yes. We have performed these tests within two projects. The first project is Viola. This is a German project. It's a German optical testbed, which is funded by the German government. And the other project is the Bubble project. And what we also did, we did tests between these two testbeds. So I will start to give you a short introduction to the UNI 2.0 signaling. Then I will describe the test scenarios, and finally I will present the test results. Let's start with a short introduction to the AZON model. Maybe you have seen it several times before. We have several domains here. These domains are connected via E and I segments. On the end, you have UNI connections. Here we have clients. These clients can, for example, be routers or gigabit Ethernet switches. And what you do, you set up a connection dynamically from this client to that client here. There are two kinds of connections. If the connection is set up by management, then it is done from this network element to that network element. Then we call these connections soft permanent connections. If the connections are set up from the client to another client, then we call them switch connections. Switch connections are initiated by the users, or for example by routers or Ethernet switches. Now let's go a little bit in detail. Here we have the model as before. What we can see here is here between client and the first network element, we have a gigabit Ethernet connection. That's normal Ethernet. And then we have the SDH connection, where the gigabit Ethernet is encapsulated until to the end network element, and then we have a gigabit Ethernet connection again. Just a short introduction into encapsulation of gigabit Ethernet into SDH. There's a protocol, GFP, which is used to encapsulate gigabit Ethernet packets into SDH. Within SDH, you can transport data either within SDS1 containers or now mostly used in VC4 containers. One VC4 container, for example, means that you have 155 megabit available. And if 1 gigabit is more than 155 megabit, for example, then you need several of these containers in order to encapsulate a full gigabit Ethernet connection. Normally, you need 7 containers for transmitting 1 gigabit Ethernet, And these 7 containers which you have, these are concatenated by virtual concatenation. This means here you have several, up to 7 SDH connections which can take different routes through your network, but they belong together by using the VCAT mechanism. LCAS is an addition, which does not have to be used, but LCAS allows you on the fly to increase the number of VC4 connections and to decrease it. Now, this is the data plane. When you want to set up these data connections, you have to use the control plane and signaling in order to set up all these data connections. And in the case of UNI 2.0, you have 2 control connections. The first control connection is only dealing with Gigabit Ethernet. So in these control connections, only the UNI client or UNI network part of both sides are involved. And for setting up these SDH VC4 connections, you use the normal SDH call setup. Now, once more, a little bit more detail. Here on the left and the right side, you have the UNI clients. Now, how does it work? The client sends a pass message to its attached network element. First, I want to mention that the signaling is done by using 2 protocols. The main protocol is RSVP-TE, but the OSPF-TE protocol is also used for distributing information in the signal network. So let's start again with the signaling. The clients want to have a Gigabit Ethernet connection. It sends a pass message, this one here, to the attached network element. Then this network element gets in contact to the SDH controller, and this SDH controller then sets up the path for the different VC4 connections. When you see this cloud here, this means this is a number of clouds, because here you have all these domains which are separated by ENNI, and the path message is sent hop by hop from one network element to the next network element. And here you can have a lot of network elements on this way up to the destination. When the path message reaches the destination, then you can send back reservation messages which conclude the reservation of the path. Sometimes confirmation messages are also sent back this way. When the SDH connections have been set up, then the Ethernet control connection is continued, and you send a path message to the far destination, which gets in contact to the far end UNI client, and then you get a reservation message back to the source of the connection. So when you do interoperability testing, you can imagine that you have a lot of messages here in order to set up these connections. And if you have errors, which is the case if you are dealing with things which are new and which have not yet been the standards have not yet been finalized, then a failure can occur at each node, and this means that you have to take care for that. This is the testbed environment which we used. At the bottom, you have the Viola testbed. Here we have different vendors. We have components from Alcatel, from Sycamore, from Siemens. Here we have Berlin. Here we have the testbed of the Deutsche Telekom, which is divided in 2 parts. They have a Muppet testbed, and they have also a DT demonstrator, which also contains Alcatel equipment. And within the Muppet testbed, they use Ericsson equipment. And what we did, we tried to set up connections from UNI clients, which are mentioned here. using all combinations which are possible. And I will now present the result. But before I do it, what kind of test did we perform? First of all, we created connections. Then, after the connections have been created, you have 4 possibilities to delete connections. You can do it in a normal way that is called graceful deletion, and this graceful deletion can be done from source or from destination. The other thing, forced deletion, means that there has been an error in your network, and then you have a different deletion protocol, and this is called forced deletion, and this can also be originated from the originating client or from the destination client. Here a short overview about the vendors which have taken part in the test. I want to mention once more, UNI 2.0 is not yet finished. The final version of the standard is expected for end of the year. And what we have got within Viola and Muppet were prototype implementations which were based on intermediate versions of the standard. So, of course, everything did not work as expected. Some words about the UNI clients. Currently, there are, I guess, no vendors which have UNI 2.0 clients already implemented in their network devices. So we have to use some proxy clients. Proxy clients are clients which simulate the control plane, which is later integrated into the network element in the routers or Ethernet switches, and instead of talking the network elements to the SDH components, the proxy client talks to these network elements. So we have 2 proxy clients, one from Alcatel. This has been developed within the context of Viola, and the other one is from Naftel. Naftel is a provider for test equipment for GMPLS and MPLS, and they have a system called Inter-Emulator, and within this system you can set up as many UNI 2.0 clients as you want, whereas in the Alcatel solution, one client could only be attached to one network element. When we did the test, we had the main tool in order to verify if the tests were okay was Wireshark, or formerly known under Ethereal. This is a packet sniffing software where you can sniff all the packets on the network, and this software allows you to investigate the protocol elements, and you need it in order to see what happens. The system on the right, ClearPond, has been developed during the OIF interoperability tests, and this is a visualization tool which shows you connections. Here you can see here we have a connection from this client to this client here. And when you want to do these tests, you have these UNI clients, you have these network elements, these SDH devices, and currently currently we have the problem that the support for UNI 2.0 is not yet integrated in the normal management systems, and therefore we also had to use a lot of configuration by using command line interfaces and so on. Now let's come to the main result of the test. At the end, after some 9 months of testing and doing interoperability tests, we were quite happy because we could set up connections between all these vendors which have been involved in the test, so it was very successful. And we could do this test for SDH, soft permanent and switch connections and for Ethernet soft permanent and switch connections. We had a lot of issues during these tests, and these issues most of these issues could be resolved during the tests. Now I will describe some of these issues. One issue is when you use signaling, you need a network in order to for these signaling messages. Normally, for network devices, the carriers use a network which is called DCN, which is used for management purposes. And for signaling, now you need an additional network which is called SCN. So you have two networks, one for control plane traffic and one for management traffic. And in the IP world, normally in-band signaling is used, so you do not have this SCN network. But in the case of SDH equipment and GMPLS signaling and UNI and all these things, you use out-of-band signaling, and therefore you need this additional network. Now you have to set up two networks, the DCN network and the SCN network. And this has been very complicated, more complicated than we thought. The first idea was to separate them completely, but that did not work. Finally, they have to be merged, and the other thing what we has to be done was we have to provide a flat network which covers all the different locations where these devices have been located. I will show it to you. Here you have these dotted lines. Here's one, and here's another, which separate the different locations where the network elements have been set up. So, for example, we have here Nuremberg, we have Erlangen, we have St. Augustin, which is near Bonn, and so on. So the testbed has been spread all over Germany. And what we have to do, what has to be done was to set up a flat Ethernet network for the signaling and for the DCN management. And we did this by using different technologies. Here, for example, we used an Ethernet which has been realized by using MPLS and using the VPLS service which is on top of MPLS. Another thing, if the sites were very far away and if there are not so many network elements, we also used Ethernet tunneling over IP using BSD workstations. So at the end, we came up with a very complicated network. Now, some other issues. We had different vendors. The management system, I already mentioned it, did not support UNI 2.0. So we had to deal with a lot of different interfaces. Some vendors use command line interfaces, others use SNMP interfaces, and others use graphical user interfaces. In the case of SNMP interfaces, unfortunately, there were different MIPs. So vendor A uses MIP A and vendor B uses MIP B. So the same things could be done with these MIPs. Now concerning the interworking, there have been some problems because the vendors have implemented different subsets of standards. Each standard has optional elements which can be implemented, and some vendors implemented these optional elements, others implemented other optional elements. And the problem with optional protocol elements is that when they arrive at an element which does not support these optional elements, then these optional elements should be ignored. But in some cases, this was not the case, so they were rejected and the call could not be set up. Then the next problem is there are various control flows for creating and keeping and deleting connections. So there is a lot of freedom within the network. For example, when a call is set up, you can have confirmation messages or no confirmation messages. When a call has been established, you can have refresh messages, or the other thing what you can do is to repeat the pass message. So you have a lot of freedom, and this causes a lot of problems. Most of these problems could be solved by just deactivating certain protocol elements, so that only a certain minimum set of protocol elements was used. I will skip this example because I do not have so much time. It just indicates that the different vendors have different meaning on certain protocol parameters. For example, what is the maximum packet size? Does it include Ethernet header or does it not? Or what is the minimum packet size? Is it only the IP payload, or is it the Ethernet payload, or is it without or including the Ethernet header? And this causes some problems. Now, the next thing I want to mention is TNA. Each Ethernet port which you want to connect to another Ethernet port has an address. This is called Transport Network Assigned Address, or TNA address. These addresses can be IP version 4 addresses, or IP version 6 addresses, or NSUB addresses. Basically, all vendors use in reality IP for version 4 addresses. The problem is that these TNA addresses have to be distributed via OSPF-TE to all sites. And if each port has its own TNA address, then you can imagine that a lot of addresses has to be distributed in a real big network. And currently, there is no summarization of TNAs at the ENNI borders. This will be part of a later version of a standard. So this can be a problem if you are dealing with very large networks. Then just one thing which was very annoying. If you see error messages, we often see this error message RSVP system error, which in reality could mean everything. And the other thing was routing error. And if you have these generic error messages, then you have some problems because you need some further information in order to find out what really happened. And this further information could often only be provided by the vendors when they use some internal debug commands which gives them this additional information. Now I would like to specify some requirements for the vendors so that things should improve in the future. For the vendors, I think it would be good if they support something like auto-discovery and auto-configuration. If you put network elements together today, you have to exactly specify the properties of the links. They are not detected automatically, and this is a very time-consuming process. The other thing I already mentioned is more and detailed information in the case of errors. And the last thing is what we need is standardized management interfaces like SNMP and XML, so that third-party management systems can also be used to set up connections. There are also some requirements towards the OIF. When we started Viola, we thought that UNI 2.0 will be finalized during the project, but during the 3 years of Viola, it was not finalized, so we still had to work with pre-releases and prototypes. And the next thing is also, I already mentioned the SCN network. Every vendor does it like he wants to do it, so a guideline for a general setup of SCN networks would be helpful, and auto-discovery should also be mentioned in the standard. Now I will come to the future activities. Viola has ended in the meantime, so we do not perform any tests now on this topic. We have written drafts for new projects which will focus on a hybrid Ethernet SDH and all optical switching based on ASON GMPLS. Maybe in such a project the activities can be continued. And the other focus of the new project is on real services for grid users, commercial services. Muppet will end at the end of 2007. Here a successor project has been written and was submitted in the first call of FP7. In September of this year, there will be a new interoperability test between a lot of vendors on UNI 2.0. The other thing, some things, part of our work will also continue in a new European project called Phosphorus, which started last year. And here a grid-enabled GMPLS control plane is developed. This will support advanced reservation and the distribution and allocation of grid and network resources. Here you find some references to the projects I mentioned. And finally, I want to mention once more that it was a successful test, though we had a lot of problems. But I also want to mention that it took a lot of time to do these tests. And finally, I want to thank all the vendors which have supported us in these tests. Thank you very much for your attention.
Thank you, Ferdinand. Very interesting. Is there a question? There's room for one question.
Yes.
So I'm just curious, is the ENNI, does that actually handle Ethernet to Ethernet or only SDH?
I think both. There are some extensions for Ethernet.
Did you use both?
I'm not quite sure about that.
One more? No. If not, then once more, thank you, Ferdinand. With this, we close the day. Thanks a lot for attending this session. I wish you a nice gala evening and see you in the harbor of Copenhagen.